Okay, so notes, composition and inverse of radical notes. So do you remember this notation? This notation is f of g of x, and that is a composition composing f and function f and function g in terms of x. Okay, let's go ahead and skip down. We're going to go ahead and start by reviewing composition. Okay, so how do you do a composition? Let's look at this first example. First of all, we are given the two functions f and g, and we are doing f of g of x. So function g is going into function f. So here's function g, and we're going to plug that into function f everywhere you see an x. So it's going to be 3 times, oh, I see an x, plug in x minus 9. Okay, keep going, plus 1. And there's your composition. Let's go ahead and simplify it real quick. This distributing, we get 3x minus 27 plus 1, and we get 3x minus 26. That represents f of g of x. Ignore that little dot there. Okay, let's look at this, g of f of x. So this time function f, that's this function up here, that's going to go into function g everywhere you see an x. Okay, so starting function g, all right, oh, there's an x. What goes in? Function f. So function f is going to go in. I'm going to go ahead and move down a little bit here, 3x plus 1. So that function went in for x. Okay, let's keep going. Minus 9. So minus 9. Remember, the original function was x minus 9. So x came out, and 3x plus 1 goes in. Okay, so let's simplify it, and we're done. Okay, let's take a look at the quadratic. Same concept. Function g is going into function f. So, starting with function f, we have 3 times, oh, there's an x. What goes in? Function g does, which is x plus 2. Okay, squared minus 5. All right, and then we can go ahead and simplify this, and we should end up with 3x squared plus 12x plus 7. So make sure you do all the work here. Make sure you square your binomial, multiply through by 3, and then combine like terms. Okay, next one. Function f is going into function g. Okay, so let's start with g. So x, oh, there's x. So what do we got to put in there? That's right, function f. So 3x squared minus 5. Okay, that got plugged into x. Okay, let's keep going. Plus 2. So we get 3x squared minus 3. And that is your answer for that composition. Okay, next one. All right, this time we have a radical or square root function and a linear function. And here we have the linear function g going into the square root function. So here we go. Starting with f, we got the square root. Oh, there's an x. What goes in? Correct. 2x minus 1. Keep going. Plus 5. Okay, so we end up with the square root of 2x plus 4. when we simplify. Okay, next one. Function f is going into function g. All right, so starting with g. 2 times, there's an x. So we have to put our square root of x plus 5 there, minus 1. And there's really nothing we can do here. We don't need the parentheses, so let's just rewrite it like this. And that is g of f of x. Okay, next one. Another radical, another square root function, and a what type of function is this? Correct, quadratic. So g is going into f. So starting with f, we have the square root. There's an x. So we plug in 4x squared. Okay, keep going. Minus 3. A lot of people forget to keep going. They plug it in and then they stop. Okay, can't do that. And we can't do anything with this function. That's done. Okay, f is going into g, so starting off with g, we have 4 times, there's an x, plugging in the square root of x minus 3. Okay, keep going, squared. What do you think? What can we do here? 4. What happens when you square a square root? That's right, they cancel each other out. Now what do we do though? What's happening with the 4 and this term here? That's right, it's multiplying. So to show multiplication, we're going to use parentheses still. The square root goes away because it was squared. Okay, distributing, we get 4x minus 12. And that is g of f of x. So there's your review on composition. Okay, so for tomorrow, we're going to talk about inverse. See if you can remember the 2 steps for finding the inverse and have those filled out for tomorrow. Okay? Thank you.